In this video, we will interpret polynomial functions in factored and graphical forms. We'll start with the factored form of a polynomial function. F of x equals 3 times x minus 7 times x plus 3 quantity squared. So this will be a cubic polynomial function because if I were to multiply everything out, x squared times x would result in x cubed. So the number of roots that I would have would be 3. And question A says to list each real zero and give its multiplicity. There is a real zero at x equals 7 with multiplicity 1. There is a real zero at x equals negative 3 with multiplicity 2. And I got that by determining the x value that would result in each factor being 0. Determine whether the graph crosses or touches the x-axis at each intercept. It will cross the x-axis at x equals 7, and it will touch or bounce the x-axis at x equals negative 3 because of that multiplicity of 2. Determine the maximum number of turning points on the graph. The maximum number of turning points is going to be 2 because it's 1 less than the degree. This is a cubic polynomial function. When we determine the end behavior, when it's a cubic function, if your leading coefficient is positive, in this case it will be positive, the right end will tend toward positive infinity. And because it's an odd function, the left end will be opposite, so it will tend toward negative infinity. Now what we're going to do is we will graph this function using Desmos, and we will verify all of our claims about the function. So I'll graph it, and it looks like this. Let's observe that the curve goes through the x-axis at 7. The curve touches the x-axis at negative 3. There are 2 turning points. The right end tends toward positive infinity, and the left end tends toward negative infinity. Now we'll look at the graphs of polynomial functions. And we're asked to verify, in fact, could these graphs represent polynomial functions and state the least degree the function can have. So my claim for the first graph is that, yes, this is a polynomial function. It is odd because the right end and the left end they're tending in different directions. There are 3 zeros at negative 1, 1, and 2. Because there are 3 zeros, the least possible degree is 3. In that second graph, this is an even polynomial function because the left end and the right end are both tending down. The leading coefficient in this case, of course, would be negative. There are 4 zeros at negative 1. Then there's a double root at 1 and 2. The least possible degree here would be 4.